The battery electric vehicle revolution is now in full swing, and the investment community is clearly on board with this trend. If we just look at the Tesla juggernaut, it has now doubled in value since its mid-May low point for the year and has recently joined the elite few companies trading above the $1 trillion market cap. Investing in Tesla is clearly becoming harder to justify, given the parabolic rise in its share price and the lofty valuation that it currently enjoys. Now, there may be some alternative BEV manufacturers that offer a compelling investment case. I personally haven't found one yet that is trading on anything other than a wing and a prayer. But there are likely others with more faith than me in companies like Xpeng, NIO, or US startups like Rivian, Lucent, or Fisker. Or even faith in the incumbent dinosaurs like Ford, GM, and VW to transform their entire business models, product lines, and supply chains to meet the challenge. Fortunately, there are other ways to invest in the BEV revolution. And I'm going to be dedicating some time in the next few videos to explore the investment case for raw materials, specifically this stuff. Lithium. Actually, this is lithium as a metal. What battery manufacturers are interested in is this stuff. Lithium carbonate, or to be more specific, lithium carbonate equivalents, or LCEs, since there are a couple of types of lithium salts that are used in battery chemistries. By far the dominant forms of LCEs are lithium carbonate and its newer competitor, lithium hydroxide. Lithium carbonate is the more widely used for now, but lithium hydroxide is becoming more popular because the chemistry is more suited for nickel-rich battery chemistries, which promise greater energy density and safety. Also, traditional cobalt-rich battery technologies are a challenge because cobalt is somewhat controversial thanks to its association with a lot of unethical mining practices, like child labor in countries like the Congo, which are rich in cobalt reserves. So now that we know what we're looking for, let's look at where LCEs come from. The most common source of lithium production today is from brines, large bodies of salty water rich in lithium mineral deposits. Basically, the lithium-rich mineral water gets pumped into surface tailing dams, and the sun then gets asked to do its thing. 6 or 7 months later, when the water has evaporated, the miners just come and scrape it up. It still needs to get purified, but the input costs in such mining techniques are relatively low. Now, one of the major advantages of this type of mining is that they can produce either lithium carbonate or lithium hydroxide. The latter is produced by chemically processing the lithium carbonate in special factories. It is interesting to note that according to recent results published by Livent, one of the world's largest lithium miners, lithium carbonate is selling as the more expensive product at present, with lithium hydroxide uptake still relatively low. This is the useful part of investing in brine-based lithium mining. They have more optionality in terms of the products they sell. Next up, we have hard rock deposits, seams of lithium compounds known as spodumene, embedded into rock. Now the idea is to crush the rock, then heat it to 1000 degrees Celsius, at which point the spodumene is chemically altered. It then gets bathed in sulfuric acid to produce lithium sulfate, which can be directly converted into lithium hydroxide. To the best of my knowledge, hard rock miners don't produce lithium carbonate. There are a number of new hard rock projects coming online, but it seems that this is a much more costly extraction method, so they are likely to be less profitable. Lithium extraction from lithium clay is also a talked about method, but to date nobody has succeeded with this commercially. Tesla has also registered a patent for this type of extraction, which is a much talked about initiative, but it also has a lot of skeptics out there wondering about the feasibility of such an approach. The last and not to be overlooked method of lithium production is recycling. A lot of money is being spent on this technology, and it is likely to become a dominant supplier in the future. But for now, this is still early days, and there simply aren't enough batteries in circulation to feed such a production line with sufficient material for recycling. Now, we've spoken about the various types of lithium and the types of mining out there. The last note I wanted to make in this video is on the supply versus demand projections. This is a chart I got from the International Energy Agency website, which demonstrates forecasted demand versus committed supply. It is blatantly apparent that lithium is going to be in a structural deficit for some time. I think these figures are fairly accurate. We can work on roughly 1 kilogram of lithium carbonate per kilowatt hour of battery. This is averaged up a bit, but it makes calculation easy. And it is estimated that the lithium battery production capacity will be approximately 1,500 gigawatt hours by 2025. Tesla alone, by the end of next year, is going to be producing 2 million cars a year, which will consume about 200,000 tons of lithium carbonate equivalent. And we can add around 40 gigawatt hours worth of megapacks to this equation. If you share my conviction that battery electric vehicles are going to be the dominant form of vehicle sold by 2030, then we are talking at least 30 million vehicles a year or 3 million tons of LCEs. You might be asking the question, yeah, but what happens if we have a technology change, like solid-state batteries? Won't that change anything? The answer is no, it won't. Solid-state batteries still use lithium. If you like this content, please hit the like button and don't forget to subscribe to my channel so that you can get updated on when I plan on posting again.